Hello, good morning. Today I just want to quickly show you how to do the graph of some of the trig functions with transformations on it. So from our previous video, we all know that there are a couple of things that we need to pay attention to when we looking at the equation of the graph. So for example, in our example number 1, we have a y equal to 3 sine x. Okay, so we know that from the look of the equations, we can write down some of the special things that we notice, such as the amplitude, okay, is the values of the a is going to be equal to 3. And the b value, which is the sorry, not the b values, the k values, okay, that goes in here, that will determine the period is going to be equal to 1. Okay, so here is where the k value is. So therefore, because of that, we know that the period is going to be equal to 2 pi over 1 over k. So still be 2 pi. Okay, so I know that the key point is going to happening in every key point is going to be happening in every 2 pi over 4, which is equal to pi over 3. Sorry, pi over 2. Okay, so on the graph, I can quickly give myself 4 equal parts, and the last will be the 2 pi, because I should have a period of 2 pi, and every quarter of it will be a pi over 2. So every key point will happen every pi over 2. So when you're adding another pi over 2, that will be a 2 pi over 2, which is a pi, which is 180. Adding another pi over 2 will give you a 3 pi over 2. Okay, and also the maximum is going to be the amplitude 3 plus the c, which is a 0. I don't have any c over here. Okay, so maximum is 3, and the minimum value is going to be the negative of the amplitude of a, so this will give me minus 3. So basically, if you can give yourself the scale along the y, and 1, 2, negative 3 down here, so you already have like all the scales of the key points. Okay, so that is basically what you need to label it before you start to graph. And because this is a sine, and the amplitude is a and the a value is a positive, so we know that the starting points for the sine functions always start at the equation of axis, and the equation of axis is y equal to 0. Okay, so that will be the because we already know from here that the c is equal to 0. Okay, so this is my starting point. Okay, since there's no phase shift, so we also notice that the d is also equal to 0. So remember, we talk about the starting point is always equal to the phase shift and the c for the sine. So that's why we have the starting point at the point of origins. So the first quarter, we always go up to the max. Second quarter, we're back to the equation of axis. The third quarter, we're going down to the minimum. And the last quarter, we're back to the equation of axis. So those are the 4 equal parts. So when you connect, all the key points. This is the graph of the 3 sine x, okay, with the amplitude. So the amplitude, again, I want to show you on the graph. The amplitude is from here, the maximum, to the middle line. So this has to be 3. And same thing over here. That will also give you the 3. Okay? So that basically is what we do with the first example. And moving on to the next one, okay? To the next one, graph of the y equal to 2 cos x minus 1. So for this one, I'm going to let me find some space here so I can kind of show you where some of the, let me just do my little details down here. So let's identify the amplitude, the absolute values of the A. So in this case, we know that this is the coefficients before the sine, the cosine. So this will have to be 2. K value. Okay, so what goes after the cos? And again, we do see no coefficients before the x, so that still be the 1. So we know that the k is equal to 1, so period must be equal to 2 pi. Okay, same thing like the previous example. So again, key points is going to be, the key point is going to be a pi over 2. Because when you take 2 pi divided by 4, you get a pi over 2 over here, and then a pi over here, and then 3 pi over 2, and then a pi. Sorry, 2 pi over here. Okay? So this is your y, this is your x. And then let's determine the maximum value. So the maximum value here is going to be the absolute values of the amplitude, which is a 2, plus the c, because it's, the c is going to be minus 1. So the maximum is going to be the amplitude of the 2, which is the 2 minus the 1, which will give you 1. Okay, so maximum is going to be at 1. Okay, now the minimum value is going to be minus the amplitude of the 2, so it's minus the 2, and then minus the 1. So minimum will give me a negative 3. So I know that on my graph. Okay, so minus 3 is going to be my minimum value here. Okay, minus 1, minus 2, minus 3. Okay, and the d value, there's no phase shift, but I know that the d value is 0 because there's no phase shift. We're not moving left or right, but we do have the c values that is equal to negative 1, which is my equation of axis. Okay, so I'm going to label the equation of axis now with this broken line, and I'm going to label the equations as a y equal to negative 1, because that will be my middle line. This is going to be my equation of axis. So unlike example number 1, where we have the x-axis as our equation of axis. So and because this is a cosine, and we already know that the starting point for the cosine is going to be the d if there's any phase shift, and maximum or minimum depends on the a value. So since the a value is a positive, so the y coordinate of the starting point has to be the maximum. So that means our starting point is going to be, the d is a 0, so it's 0, and the maximum is 1. So 0 and 1 is right here. So this is my starting point. Okay, so in this case, it's going to be a 0 and 1. Okay, so the first quarter, we're going down to the middle line. The second quarter, we'll go down to the minimum. And the third quarter, we're back to the middle line again. And the last quarter, we're back to the maximum. Okay? So when you connect all of this point with a smooth curve, okay? And this is going to be the one cycle of the 2 cos x minus 1. So everything pretty much is the coming down 1 unit, okay? And because of the amplitude of 2, so as you can see, the distance between the middle line and the minimum, that distance is 2 units. And same thing, from the middle line to the maximum, this distance is also 2 units. Okay, so that is example number 2. And let me just do one more, okay? One more, because this one has the amplitude that is equal to the negative. So I want to show you how some of the things might get changed, okay? So right now, we have, let me just do my little details up here, okay? Maybe this is easy to see it. So right here, I have the amplitude of the A. That means I'm going to have absolute values of the negative 3, but that will also give me a 3. So amplitude is equal to 3. The K value, same thing, is 1, okay, because you don't see any coefficients beside or in front of the X. So that means the period still be equal to 2 pi. 2 pi over 1 is 2 pi. So again, that means if I'm going to give myself 4 equal parts, I still get the same thing here, okay? We're still not doing example with the phase shift yet, okay? So I have a pi over 2, I have a pi here, 3 pi over 2 here, and then a 2 pi, okay? So, but we still need to find the maximum value where the graph go to, okay? And we have the amplitude of A, which is a 3, and the C value is 2. So we have a maximum values of 5, okay? So up here, you can pretty much do 1, 2, 3, 4, 5. So you can mark the scales along the y-axis. And the minimum is the negative of the amplitude, so which is a 3, and plus the 2, so I get a negative 1. So I know that down here, I will have the minimum of a negative 1, okay? So this one has no phase shift. The D is 0, but the C actually is equal to 2, okay? So we know that up here at 2, I should have my equation of axis. So I should have this broken line here showing with the equations y equal to 2, okay, because the C is equal to 2. So now, because this is a cosine, so again, my starting point should be, sorry, I should be using a red here so you can see, should be a D, and because the amplitude is a negative, so instead of a maximum, I should start with the minimum, okay? So this value here, it will be a 0, and the minimum is a negative 1. So this should be my starting point. So my starting point should be a 0 and a negative 1 down here. Okay, so the first quarter, I'm going to the middle line. Second quarter, I'm going up to the maximum. And the third quarter, I'm down to the middle line. and the last quarter, I'm down to the minimum. So where I start is where I end, okay, for the cosine. So slowly, if you connect all of this, okay, with a smooth curve, so this is the cosine functions with the upside down because it actually flipped because of the negative a. Okay, so this is what you should have, and the amplitude is 3. So from here, the distance from here to the maximum is 3 units, 1, 2, 3, and also the distance from the middle line to the minimum is also 3, 1, 2, 3. Okay,